Okay. So, here goes. Be with me because this lesson is not going to explain itself. So, it goes a little something like this. First, let's review what you should know that you hopefully are thinking is easy. If I asked you to convert 4 plus 3i to polar form, how do you do it? Draw. What is 4, horizontal or vertical? To the right. And what is 3? Up. Okay? This typically is called r, and this is theta. How do you find r? Pythagorean theorem. Okay? And so isn't r the square root of 3 squared plus 4 squared, or 5? That's, I guess I should sing all the way along. 5, yeah? Okay, and what about yield theta? Inverse tangent of 3 over 4 or 4 over 3? Opposite over adjacent, 3 over 4. Okay? Inverse tangent of 3 over 4 is? Inverse tangent of 3 over 4 is 36.869. Sometimes we have to add 180 or subtract from 180 or subtract from 360. Do we have to do any of that here? No. So we would say this is 5 cosine I sine 36.869 degrees. Is that part in your head and going well? Okay, cool. There is a shortcut for multiplying two things in polar. What's the shortcut? What do you do with the 2 and the 4, Mr. McCabe? Multiply. And what do you do with the angles, Maya? Add. Okay? Unless they specify, you can probably leave the answer in the same form it was given, so I guess I'll just leave it in. Is this rectangular or polar? The vocabulary is important. This is polar. Okay? It's getting to directions to a place based on turning an angle and going out from the pole. Rectangular is going right, left, up, and down like you drive streets kind of thing. All right. Now, leading into today's then, would you do that next one, please? Actually, let's go. All right, ready? So the number up front, okay? 27, wonderful. And the angle?
30.
30, yes. All right. So my question is, what if instead of being 3 of those, you can see they're all the same now? Okay. What if there were 100? 3 to the hundredth, because you would multiply all the 3's together, so it would be 3 to the 100th. And what about the angle? Would you multiply times 100? So it would be 10 degrees times 100, yeah? All right, that's de Moivre's theorem that you just did. De Moivre's theorem, it's a French guy, all right? So de Moivre's theorem is used for complex expansion and finding complex roots. It has lots of uses we'll get to, but let's start here. If you get a polar number to a power, then the number out front, we multiply all those together, right? What do we say? 3 times 3 times 3? So it's 3 to the third. And the angle, we add all those, so it's adding 10 to itself 3 times. So that's 10 times 3. So our answer is 27 cosine I sine 30. You follow me? Okay, the formula then is when you have a polar number to a power, the number out front, you actually use that exponent, but the angle you multiply by the exponent. You see? Note yourself, the shortcut can only be used in polar form. There is no rectangular form shortcut of de Moivre. So if they give you rectangular, the first thing you gotta do is say, all right, I guess I gotta put in polar. So like this. So if I have 1 plus I to the 13th power, it's actually kind of fun. We'll do this eventually, but we could actually do this 2 ways. We could do all this binomial expansion stuff, like a plus b to the 13th, yeah? Yeah, we could. And it would be lots of fun. And we have to do 14 rows of Pascal's triangle. But with the Moivre's theorem, we could do this in a little different way. First thing is you must go to polar. To polar, let's graph this. Isn't it right one, up one? So will you please tell me what the polar form is? What's the hypotenuse? No. What? You are killing me. Are you trying to kill me? Root 2, thank you. Root 2, the angle?
45.
45. We'll use degrees pretty much all day. All right. Now that that's done, we can use de Moivre's theorem. De Moivre's theorem says, I would have, if I had 13 of these, wouldn't the root 2, I would actually multiply all those root 2's together. So this then is root 2 to the 13th. The angle, do we take it to the 13th, or do we multiply it by 13? Multiply it by 13. All right. Root 2 to the 13th, let's clean that up a little. Wouldn't you say that's root 2 to the 12th times an extra root 2? You follow me? And what is root 2 to the 12th? But normal 2 to the 6. So what's normal 2 to the 6? 64. Okay, so this is 64 root 2 cosine I sine, and what do we got there? 45 times 10 is 450. 45 times 3 is 135. 450 plus 135 is 585. All right. Now, if the question, so we have done the problem technically. We took it to the 13. The question is, what form do they want? If the original problem is in rectangular, you should probably answer in rectangular. That's common math procedure. Use the form they gave you. So now we have to take 64 root 2 cosine 585 plus 64 root 2 sine 585i and put it back in rectangular. What's 585 degrees in an easier way? 225. 64 root 2 cosine of 225 and 225. You follow me? What's cosine of 225? Negative root 2 over 2. And what is sine of 225? Negative root 2 over 2. All right, we're almost done. A 2 goes into 64, and that's 32. And what's root 2 times root 2? 2. And so 32 times another 2 back is negative 64. Right? And this is identical, so it's also 64, but this time with an I. And we're done. You follow? Okay, now these are powers. They're the easier ones. Roots are the harder ones, so let's go to roots. All right, now you could say it's not really that different because isn't every root also a power? So if you say find the cube roots, there are 3 of them, of 8 cosine I sine 36, the first thing you should do, as the blinking note indicates, is make this a fraction exponent. What is the cube root the same as? What power? Cube root is the same as 1/3 as a power. All right? So first thing you should do is write the root as a power, as a fraction power. You dig? Okay, so now we do De Moivre's theorem. This is 8 to the 1/3, and the angle is times 1/3, right? Because that's what the idea of the day is. The first number you actually take to the exponent, the second number you multiply by the exponent. Are we cool? So what is 8 to the 1/3? 2. And what is 36 divided by 3? 12. All right. Now, this is a little like when we solve, remember when we solve cosine of 3x equals 1? Because we're going to eventually divide by 3, we can go around 3 times, yeah? The same will go here, 2 pi over 3 and so on. Because we, in effect, divided the angle by 3, we're actually going to get 3 different solutions. So one is this guy. One is if you took how shall I do this? Go this way. Okay. Another is if you had, instead of 36, you had 396. So if you look at the original problem was 8 cosine of 36, cosine of 36. If you went 360 around again, you would get 396. If you then cube rooted, you would get 2 cosine I sine. And what's 396 divided by 3, or times a third? 132. Right? Likewise, you could go around one more time. If you started at 36 and went 720, then that would be 8 cosine I sine. What's 720 plus 36? That's not hard. 720 plus 36. 756. If you then took that to the 1/3, what do you get? 2 cosine I sine. What's 1/3 of 756? 252. Now, that's a little gross, but there's a bit of a shortcut here. Instead of doing this 396 and 756 idea, we could shorten this up and say, if you look at all 3 solutions, all of them have the same 2 cosine I sine. That's not difficult, right? So we're all good there. We don't have to redo that every time. What do you notice about all the solutions? The solutions are all how far apart? 120 apart. Where do you reckon that came from? Yeah, each time we went around 360, but then we later divided by 3. So we can say that solutions on these are 360 divided by, you reckon it's always divided by 3, but what if it's square root? And it would be, so it's really 360 divided by the root apart. In this case, the root was a cube root, so they're all 360 divided by 3 apart, or 120 apart. In a square root problem, they'd be 360 divided by 2, or 180 apart. So let's try another one. Find the 2 square roots of 1. This doesn't even feel like one of those problems, because 1, come on, that's not even polar, in rectangular form. Let's first go to polar. What is 1 the same as in this actual normal form? Where's the I? What's the I? So this is 1 plus 0I, okay? And if I go to polar, kind of a weird triangle. Do I go right, left, up, or down? Just go right 1, So that's 1 cosine I sine at what angle? To the 0. Now because it's square root, isn't that the same as the 1/2 power? So you're going to write in polar form. Done. Now we're going to use the mob to get the first solution. Remember, the idea of the day is the number out front. What do you do with it in the exponent? Do you multiply it by that, or do you actually take it to the 1/2 power? Take it to the 1/2 power. What about the angle? Do you multiply that, or take it to the 1/2 power? You multiply that. So the first solution is 1 cosine I sine 0. You dig? Okay? Find all the other solutions. To find all the other solutions, you find the spacing between them. It's going to be 360 degrees divided by however many solutions there are. They are evenly spaced. It says there are 2 solutions. The square root is 2, so we divide by 2. So the next solution is 180 degrees apart. So the next solution is 1 cosine I sine 180. And in this case, then, there is a step 4. You have to go back to rectangular. The question says put them in rectangular form. These are polar form. The one with the angles and the magnitude, if you talk vector form, is polar. So how do I take 1 cosine I sine 0 degrees back to rectangular? 1 cosine 0 plus 1 sine 0 I. What is the cosine of 0? 1. And what's the sine of 0? 0. So I get 1 plus 0 I, or just 1 if you like. And what about 1 cosine I sine 180? 1 times the cosine of 180 and 1 times the sine of 180. What's the cosine of 180? Negative 1. And the sine of 180? 0. So that's negative 1 plus 0. I could check that and say, are those squared equal to 1? And you would see that they are. Okay, last one. We'll do an ugly one. And then we'll be good. All right. Find the 5/5 roots of negative 1 and give them in rectangular form. All right, so what do I got to do first? You have to go to polar. All right, so polar. 0 minus 1i is really what this is to the 1/5 power. And we want to put this in polar. If I graph this, is this right, left, up, or down? Down. And how many units down? 1. So in polar form, this is blank cosine I sine blank. What's the magnitude? How far out do I go? 1 unit. And what's the angle? 270. Okay. Got it in polar. Now let's go and get our first solution. Right? So the number out front, 1 to the 1/5 is 1. And the angle is 270 divided by 5, or times 1/5 if you like. What's 1/5 of 270? 54, I agree, 54 degrees. All right. Now we want to get the other solutions. How many other solutions are there? There are 5 solutions altogether. We've got 1, so we need another 4 solutions, spacing. How far apart are all these answers? If there are 5 answers and we divide 360 among 5 answers so they're evenly spaced, then the spacing is 72. All right, so if I add 72 to this first angle, my second solution is 1 cosine I sine 126. If I add 72 to that, then my next solution is 1 cosine I sine 198. If I add 72 to that, I get 1 cosine I sine 270. And if I add 72 to that, I get 1 cosine I sine 342. Question for you, why stop at 5? Why not just keep adding 72 besides the fact you have life? Yeah, if you do it again, don't you get something like 414? 414 is the same as 54. So you'll start getting the same angles again if you kept going, so there's no point in it. So you have 1, 2, 3, 4, 5 solutions. Am I done? Oh man, that sucks. Now I need to go back to rectangular. Is that rectangular? Are those reference angles? No. So say you did, let's just do one of them in polar to save some time. How would I do this one in polar? Or rectangular, excuse me. 1 cosine of 54 and 1 sine of 54, and then I go calculator and so on. Yeah? All right. So let's just call it. You with me? Okay. Now, as much as I'd like to say, let's go homework, this requires practice. So, let's just do it on this bad boy. Would you try this one and see if you can do this on your little lonesome? You can imagine this takes a couple days till it gets to mastery. It's not self-evident. And we'll just randomly call in somebody to see how we did. Hopefully they're working all the way from Amigos. That's not easy. Are you ready? Okay. Do I need to convert anything, or it's already good to go in polar? Good to go. What does 4th root mean? What power? Okay. 1/4 power. So what do I do with the 16, Ms. Reeves? To the 1/4 power. Yes, true. And what is 16 to the 1/4? 2. And what about the angle? Do you take it to the 4th or divide it by 4, Katie? Urban? Times 1/4. True. Okay, so is your first solution 2 cosine I sine 15, people? Yes. Excellent. All right. What's the spacing between that and the next solution? 90. Where'd you get 90 from? 360 divided by 4th root, so 90 apart. So the next one is at 2 cosine I sine 90 plus 15, or 105, then 195, then 285. Did we win? Try that one, that's harder. No. We don't want to practice it, it's rush into doing your own. sure you're off on the right track. Did you get one cosine sine 90 for the polar form? Okay, so what's your first polar solution? Ms. Laura, what is your first polar solution?
1/3 cosine I sine 30.
Yes, 1 to the 1/3, which I'll just take as 1 cosine I sine 30. What's your second solution, Mr. O'Connor? Okay, and your third solution, Julie? You don't know? Okay, so these are 360 divided by 3 apart, or 120 apart. We just left off with 150. So the next one is 270. Okay? Now are we done? Unfortunately, no, because those are polar and they want rectangular. So what is 1 cosine of 30, or just cosine of 30? Root 3 over 2, and what is sine of 30? 1/2 I. What about cosine of 150? Negative root 3 over 2, and what about the sine? Is it still positive? Yes. And what about 270? 0 minus 1 I. So if I took all those to the third power, they should give me I, right? Okay, that is the lesson. It takes practice. Use your notes for a couple days, but then try and use your notes less and less as you go. And you'll be fine with practice. If you slept through this lesson, you're pretty well screwed. You're not going to figure this out on your own. Sorry. Do-do-do.